creating and altering views. The objectives for this nugget are to get you familiar with how to properly design a data access layer using views, and some neat things along the way to help with manageability and scalability of our underlying tables. So we'll start this nugget with a whiteboard talking about what benefits views bring to our data access layer. We'll also talk about partition tables, get a feel for what they're all about, and also partitioned views, a couple of great strategies that we can employ that will help us out with manageability, scalability, and even performance to an extent. Then we will jump into the virtual nugget lab. We'll learn how to create views. We'll see how to create that data access layer using a view to mask the underlying complexities of our table structures. We'll then jump into a partition tables demo. We'll see how to set up partitioning at the file level. Partition tables are a great way to take a huge table and splice it up into smaller, more manageable chunks. Then we will take a look at how to set up a partitioned view, which is similar to a partition table, but rather than at the file level, we're at the database level. So we can break up our big honking tables into smaller, more manageable tables and create a partition view to bring all of that data together. Let's get to it. So views are really just virtual tables. They're a lot like stored procedures in the sense that we can store a query on the server side and then just call that query. Now, with views, though, we cannot have complex logic like we can in stored procedures. We can't pass parameters to them and all that, but it's just simply a virtual table, and they're a great way to abstract the complexities of the underlying database. So that's one of the greatest benefits of view, abstraction, because we can take our big complex queries and put them inside of a view, and then our users can do whatever they need to do, whether they're programmers accessing our underlying structures or report writers that need to build reports. We can simplify that underlying structure and make it look easy to work with. So it's attractive to anybody using our database. Not like, hey, view, you're looking good today, but easy to work with, attractive. So abstraction's a big one. Another one here, simplifies data access. This is just like stored procedures. We can funnel all of our traffic from our front ends through views and stored procedures, and we know where everybody's coming from, and we can focus on just that area for data access. Also, security is a big one. This goes along with ownership chaining. We don't have to give access to the underlying tables. We simply give access to our views, and they'll automatically have access to everything underneath. So it makes it really easy to give permissions and manage security at that level. Consistency and compatibility is another one. If we need to change our underlying structures, not a big deal. We can change our views to match what front-end applications expect, and we will not break those applications. It's also worth mentioning that we can index our views to get some performance boosts, and you can insert an update into a view as well. So between views and stored procedures, we have enough diversity there where we can use views to abstract and store queries. We can use stored procedures to process complex business logic. And between them both, we can create a pretty solid data access layer. We have a couple of design philosophies to cover in this objective: partition views and partition tables. Both of these solve the problem of managing large tables. Let's start with partition views. And let's say that we had a big honkin' sales table out there that was 60 gigabytes in size. So this table is a bear. It's tough to manage. It's tough to maintain. Performance isn't that great. And obviously scalability here is nil. It's nothing. So in the world of partition views, what we could do is we could take this sales table and break it up across what are known as member tables. These member tables just store a slice of data. So we would pick a partitioning column. In this case, we could make a year column, and then we would put only that year's data in each member table. We could then create a view that pulls all of that data together. Now, to anything consuming this view, whether it's a user or an application, they're going to see this as one single entity. It's just one table to them. So if they write a query against this view to say, give me everything from VW sales history where the year equals 2011, the query optimizer is only going to grab that data from 2011. It's going to ignore these other two tables. So you will get a performance boost out of it at that level. And another really nice thing here is you could put these on different disks. You could put your cold data, your older data that doesn't get hit very often on a less expensive disk, and you can put your warm and hot data on bigger, better disks, so you can get the benefits there as well. And another nice thing here is inserting or updating data through this view. SQL will figure out, based on our partitioning column, which I'll show you when we get in the virtual nugget lab how that all works. It will insert data into the appropriate table. So partition views are just great. They're great because we can take a large table and split it up, but they're also great because it improves concurrency, less locking going on than what we would have on this big honking table, and we can get a performance boost. And on the manageability side, it's a lot easier to manage these small tables. We can create backup strategies that back up our current data more often than our older data. We could really take this to the next level and set up what are called distributed partition views. And you do that by planning your member tables on separate instances of SQL Server, set up a linked server, and then your view just pulls all that data together across the tables that are on separate instances of SQL Server. So that's called a distributed partition view, and that's how you could introduce scalability into the mix. Partition tables approach the problem a little bit differently. The end result is the same here. We're just trying to break up this big table into smaller, more manageable chunks. But with partition tables, we do that at the file system level. We create file groups, we put files in those file groups, and then we create what's called a partition function, which is just going to determine how these rows are horizontally split up. And the partition scheme then uses that function to put the data into the appropriate file. So when we read or write data from this table, the query optimizer will know where that data is. So on a read, it can do what's called partition elimination, meaning it can completely ignore a partition because it knows where the data is, and that will give us a little performance boost. And when we write data, same thing. It'll put it into the right area based on where that data lives. So we can get performance benefits out of it, but again, this is mainly used for management benefits because once again, if we can back up now at the file level and we can ensure that our warm data, our hot data, our current data is backed up more frequently than our cold or old data. And we can also do partition switching, which is something we cover heavily in 70-462. So know that partition tables and views are just a way that we can distribute data across multiple partitions in order to manage large quantities of data. Let's jump into the virtual Nugget Lab and see how all this stuff works. All right, so we're in. Let's bring up SQL Server Management Studio. We have a new project in our solution, 13.views. We're going to start here with just some basics of creating views. Again, the big points here that we want to make, and that I think Microsoft wants us to know here for the exam and the objectives, is views allow us to abstract database complexity. And you can see that in the first one here. We've got a simple view that'll bring back learner data. Now, a really good example of this is if you have an XML column. This is a great way to hide that complexity. So we're going to extract only the information we need out of that XML column and bring it back as a view. So if I just execute the query, here's the results. So we get all of our learner information here. We're wrapping the complexity inside of the view, and we also have some subqueries here to get some of our aggregations. But if we were to create this view, now we could simply give it to anybody that wanted to work with it, whether that be a developer or a report writer. They have a simple way to consume the data inside of our underlying complex structure. With that view created, we can use it just like it's a table. Give us everything where course request is not null, and there it is. See, they can work with our XML column like it was a real column inside of the underlying table. Now let's alter that view. This time we'll add encryption to it. Encryption works just like it does with stored procedures. It will obfuscate the definition, so you won't be able to get at it again. So that's why I always make sure that you have your source stored somewhere safe. But I'm also showing you here how you can re-alias the output, because these aliases up here will actually override the aliases in our query. And this will be a good one to do if, again, your definition changes. You can just re-alias it to match what applications expect. Now here we're going to alter it, and we're actually going to change our course request to course request 1. So if we were on the outside, we had reports running off this, we just broke our reports. Let's do the opposite. Let's change this to course request 1 and this to course request. So let's say the underlying schema changed, the underlying table schema that this query is running off of changed. We can just alter the view to match up what the application expects, and now it will work as expected. And also permission management. We can grant permission to our users and logins here at the view level, and they would have access to the view, but not the underlying objects that the view is using. So there's a couple of examples on what views are good for. Just remember for exam purposes that they're an abstraction layer, they can simplify security, and they can help us maintain backwards compatibility. Let's move on to partition tables. And we have a great sample table inside of our database that would make a good candidate here for partitioning, and that would be our learner nugget activity table. Again, let's say this is a huge honking table. Right now we have like 1 million records. Actually, we have close to 1 million in our archive table. We'll use that one with partition views. For our learner nugget activity table, Let's say that we wanted to break this table up by quarter. So underneath the hood, we wanted on the file system a different file for each quarter of data that goes in here. So right now we have all 2013 data within here, like 60,000 plus records. And so what we're going to do is take this table and break it up into smaller, more manageable pieces. And we're actually going to create a new table based on this table. We'll call it learner nugget activity underscore partitioned. So here's how this process works. First, we need to add some file groups to host the files that are going to contain the data. So let's do that. Let's create the file groups. All right, those are good. The next thing we need to do here is create the files and add them to their respective file groups. So for this demo, we're just going to do one file per file group. So we're going to create 4 files here. NDDB1 through 4, all stored on the file system, all in their respective file groups. So let's do that. Let's just create all of these files, plant them in their file groups, and now we can actually see this if we right-click on the database, head into Properties, go into Files. There are the 4 files we just created. And if we go to File Groups, we can see the 4 file groups, and we can see that there is one file in each file group. So we're set up at the file system level. We have our containers ready to go. The next thing is to create what's called a partition function. And this is how we're going to define our data splits, how we're going to horizontally partition that data across those files. So we're going to create a partition function here on a date time column, and your ranges here just define your boundaries. It's either going to be left or it's going to be right. So if it's right in this scenario, we're going to say everything prior to this date is 1, is our first bucket. Everything greater than or equal to this date, but less than or equal to our second date is going to go into our second bucket. Everything greater than or equal to this date and less than or equal to this date, our third bucket. And then everything on or after this date is going to be our fourth bucket. So this partition function then is just deciding how our data is split up. Our partition scheme then is going to be based on that function, and it's going to map those boundaries to our file groups. And for a visual here, I just commented exactly what data is going into what bucket. So a lot of people, when they see that we only have 3 here, they're like, hey, where's the fourth? But there's really 4 here because there's before, there's between, and then after. So those are all 4 buckets that we're setting up. All right, so let's create our function and create our scheme. All right, very good. Now we can create a table based on our partition scheme. And you can also do partition indexes as well. So you can create an index on this scheme, and that will actually then splice the index up across all of these file groups as well. But when you do create this, you're going to specify on a scheme, pass in the column. This is going to be your partition column. This data type needs to match up with your partition function because that is what it's going to use, is the values in that column to determine the splitting. So let's create this table. It's the exact same table as our learner nugget activity. It just has partitioned on the end of it, and it's tied to our partition scheme rather than the primary file group. All right, so let's do that. That will create the table. And now let's load the table up. We're going to load the table here with all the data inside of our learner nugget activity table, which right now contains only 2013 data. So loading this into this table, doing this insert, should split it up. SQL will use the scheme and the function to split it up across all of those file groups based on that time there, the action time. So 62,000 rows went in. How do you see it? Well, we've got a nice system view here, a couple of system views to see this. We can just run it against the partitions, join to the tables, and here it is. Check it out. Here are the rows broken out per bucket, per partition. And you can see we don't have any data in the fourth quarter yet, so that's why we only have data spread across the first 3 quarters. How about we do an insert? Let's do an insert, just a simple insert statement that'll do it for today's date, which is in the fourth quarter. So by executing this and then rerunning our partition query, we should now have 1 row inside of that fourth bucket, inside of that fourth file. Excellent. So that works good. So now that that big table is broken up across multiple files, if we look at them in the file system, here they are. Any sort of management or maintenance task or even data task just became a whole lot easier because we can do it at the file level. Now let's move on to partition views. Now partition views is just another way of accomplishing the same thing, managing large tables. Only we're going to get there a little bit differently here. What we're going to first do is we need to create our member tables. So these are going to be tables that contain their specific slice of data. So we're going to create 3 tables here, 1 for each year. And what we're going to do this time is use our archive table and break up that data across these three different tables. Now, to really make this work so we can actually insert data through our view is we're going to need to create a column that is going to be our partition column. So we want to do this based on a year. So we're going to create a column called action year, which also needs to be a part of your key. That's the only way that we'll be able to actually update data. Now, if you only care about reading, not updating, then you do not have to do this extra step. You can still create a view that spans all your member tables. You just won't be able to insert into it. But we're going to enforce, whenever we insert data through that view, SQL Server is going to enforce that using a check constraint. So that's why we need to set up our partition column, and then we also need to put a constraint on that to ensure that only data for that year goes into this table. Again, we also make it a part of our primary key. So we do that for each table. So we've got one for 2010, 2011, and 2012. So let's create these three tables. Excellent. And the next thing we're going to do then is just load those tables up with their specific data. So we've got insert select statements, three of them, one for each table that just models the data going into it for each year. So this will do exactly that. It'll break it up. So all three of those tables are going to have their respective data. Each one of them is going to have 93,000 plus rows into it. Now we can create our view. Now this is the easy part because you're just creating a view that's going to union all of that data together. There we go. We now have ourselves a partition view. And now anybody can use this view like a normal view, not knowing that underneath it's actually hitting three different member tables. See that? So that one pulled data back from all three tables. Now here's the interesting thing. Watch this. Let's show our execution plan. Hit execute. And if we look at it, you can see that it hit all three tables. Now, what about our next query? This is only going to pull data back from the year 2012. If we look at this, see how fast that was? And we look at execution plan, it only hit that table. So the query optimizer here is smart enough to know where the data lives, and it will only hit the tables that it needs to pull out the data. So that's where you get the added bonus of performance when you do this kind of thing. And now we can insert directly against this view because we did meet the requirements. We set up a check constraint, and we also added our partition column as part of the key. So we're inserting directly against our view. Let's change this to 2011 here. And also this. First, let's just run this one more time and see the results. How many do we have here? 93,709. All right, so we should have 93,710 after this insert statement. Oh, we need to change our year here too. 2011. There we go. All right, so let's run that insert statement. All right. And now let's look at 2011. We should have one more row, and we do. Very cool. So that is how we can create and use partition views. In this CBT nugget, we learned how to create and alter views. We started off with view design and talked about the benefits that views bring to us. The big ones being abstraction, simplified security, and maintaining backwards compatibility. We also saw what partition tables and views are all about, a great way to splice up big tables and make them more manageable. Then we jumped into the virtual Nugget Lab. We saw how to create views. We saw firsthand what some of those benefits are all about, how to abstract a complex data layer and also maintain backwards compatibility. We saw how to create a partition table. We took a huge table and spliced it up across the file system. Then we saw how to work with partition views and take a huge table and splice it up across multiple smaller member tables and bring them all together through a view. We also saw how to make that an updatable partition view by following the rules with check constraints and making that partition column a part of our key. I hope this has been informative for you, and I'd like to thank you for viewing.